Today we're going to talk about factoring polynomials by grouping. Okay, this is a special kind and it only works when we have 4 terms. Okay, so factor by grouping is a type of factoring that uses the distributive property to factor polynomials with 4 terms. Okay, sometimes you can factor a polynomial by grouping into 2 groups of terms and factoring the GCF out of each group. Again, only works when we have 4 terms. Okay, so let's look at this example. Steps for grouping with 4 terms. Group the terms into 2 groups of 2 terms each. So normally, 90% of the time, you can just group the first 2 terms and the last 2 terms. You always want to have a plus between it. We'll do an example in a few minutes that has a minus, and I'll show you what to do. But you always want to keep a plus there. Okay, then you look at these first 2 terms and you ask what the GCF from both of them is. So what is the GCF from these 2 terms? We can take out an x, and there's 3 and 2, so I can take out 2 x's, because remember it's the smallest exponent. Okay, hopefully you're going to get used to doing this in your head instead of writing it underneath like we did yesterday. If I have 3 x's, I take 2 away. I'm left with 1, because remember we are dividing. If I have 2 x's, I take 2 away. I'm just left with 4 there. Okay. Then here, what number will go into 6 and 24? 6. I have an x, but no x, so I can't do that. So 6 divided by 6 leaves me x. 24 divided by 6 leaves me 4. Okay. So group, GCF, GCF. Okay, then you're going to look at this, and you're going to be like, something looks the same. So we're going to look and see if we can find what looks the same. This one has an x plus 4, and this one has an x plus 4. So they both have a GCF now, because there's 1 term, 2 terms in this part here, and they both have a GCF of x plus 4. So we're going to write that down, and then we're going to take our pencil and we're going to mark it out. Okay? And then we're going to write the leftovers. So x squared is left, and 6. Now, how could I check this? I could use my box method and multiply this out, and I would get the same thing. Because remember, when you factor, you're not doing anything to the problem. You're just rearranging how the problem's written. Okay, so let's look at a couple more examples, and then I'm going to let you do some on your own. Okay, so we're going to group the first 2 and the last 2. We're going to look at the first 2. Oh, I can take out an x squared. I have 3. I take 2 away, so 1 is left. Those 2 cancel, and that just leaves me 2. Remember, when you distribute, you should be able to get the same thing you started with. Okay, then we're going to look at the next group here, and we're going to ask ourselves, what can go into 3 and 6? That's a 3. I am dividing. 3 divided by 3 is 1. So that's 1x. 6 divided by 3 is 2. Okay, so here I am, and I'm looking, and now I'm still trying to see what they have in common. So this one has an x plus 2. This has an x plus 2. So I'm going to write that down, because that's my common factor now. Mark it out, and then I'm going to write down the remainder. Again, I can check it by doing the box method or distributive property and multiply it, and I should get the same answer. Okay, if we look here, we have a minus. So when we group these together, you're going to want to group the minus with the number and put a plus. So the plus should always be between the 2 groupings, always. All right, so we're looking at this first grouping, and you're going to have an x squared again, and that's going to leave me x plus 9. When I divide. Again, distribute, should get the same. Now we have this here. If you have a negative 2 here and a negative 18, they're both negative, so I can take out a negative number, and I ask myself, 2 and 18 would be a 2. Can't do the x's. So negative 2 divided by negative 2 is 1. Negative 18 divided by negative 2 is positive 9. Okay, if you don't take out that negative, you would not get the same. And if you don't get the same, you did something wrong. Okay, these 2 are just the same. And your parentheses should always be, we're going to mark those out. and then we're going to write down what we have left over. Again, I can multiply to go back. Okay, so let's look at this next one here. Group the first two, group the last two, plus in between. We ask ourselves what will go into 5 and 25. That'll be 5. There's 3 x's and 2 x's, so I can take out x squared. 5 divided by 5 is 1. It's understood to be there, and then just an x. 25 divided by 5 is 5, and the x's cancel. Okay, we're looking here. What will go into x and 5? Well, number's not, and there's not x, but what will divide into anything? 1. You always have to take out a GCF. So then that just leaves me x plus 5. And then you're going to underline what's in the parentheses because they should always be the same. Mark them out, and you're left with 5x squared plus 1. Okay, so let's look at this next one here, and then we're going to do this one. I'm going to let you do this along here. All right, so we're going to group the first two, group the last two. Here I can take out an x squared. That leaves me x plus 9. 4 and 36 will give me 4. This has an x, that doesn't have an x. This has a y, that has a y, so I can take out a y. So the 4's cancels, the y's cancels, leaves me an x when I divide there. 4 going to 36 9 times, and there's no y. This will give you a hint on how this one should look because they should look the same. Okay, so we're going to have x plus 9, and that leaves me x squared plus 4y. Okay, if you'll stop the video and do this one. All right, so hopefully you grouped it like that when you did the video, and you're going to get 4x squared. That's going to leave you x plus 1. Remember that. Okay, remember 4 divided by 4 is 1. You have to have something here. Take out a 6, x plus 1. Okay, now underline these two. You're going to have x plus 1, and then you're going to be left with 4x squared plus 6. Now here's where we're going to do a little learning on the next scale. If you notice, we checked these. This one and this one has a greatest common factor. There's something where we go into 4 and a 6. So that is 2. So sometimes when you get to the end, you have to check because you forgot to do it in the beginning. So this is going to be something we're going to talk about. So let's look at this one here. You should always check for a greatest common factor out of all of them first. And that's going to be very important when we start learning to do trinomials, because we have a different method that you can also use. And if you don't check for it, your answer will be wrong. So here, I can take out an x out of all of them. And that's going to leave me 5x squared plus 3x plus 40x plus 24. Okay, so do you see that there? Okay, everybody follow along what I did there. Don't combine these, okay? Don't combine these. All right, we're going to take this x, we're going to bring it down here and forget about it. But I need it in my answer to go back to the original problem. Now we're going to do 5x squared plus 3x plus 40x plus 24. Okay, if I look here, I can take out an x, and that's going to leave me 5x plus 3. What will go into 40 and 24? An 8, and that's going to leave me 5x plus 3. Because 8 times 5 is 40, 8 times 3 is 24. Okay, if I look here, there's what's in common, so I'm going to write it down here with this x that I took out in the beginning, and then I'm going to write my leftover. Now, yes, you are going to have to practice this. Yes, this is new, but this is something that you can do, so you need to make sure you check your plan book and do your practice problems. Have a good day.